So let us now solve one problem from the thermodynamics of TIFR 2025 question paper. So the problem states that a classical ideal gas of temperature T is placed in a spherical symmetrical potential. The potential is given VR equal to CRQ, where VR as a function of R is per particle. What is the value of VR per particle? So the problem is a classical ideal gas potential potential is given as VR equal to CR cube. We need to find VR per particle, right? We recall that in a canonical ensemble, the probability density in the configuration space is so in the canonical ensemble, the probability density in configuration, the probability density in the configuration space, density in configuration space is PR. We can write is proportional e to the power beta into V into VR, right? So the mean potential energy is therefore the mean potential energy is EQRBR e to the power minus beta VR divided by dq r equal beta VR. So with beta equal to 1 by kt, right? For any spherically symmetric potential in the form of for any for any spherical for any spherically potential of the form VR equal to a r to the power n, there is a standard relation derivable via integrating by parts of the equipartition like theorem for potential energy contribution that gives VR function is equal to 3 by 2 kt, or here we have n equal to 3. Therefore, we can write VR equal to 3 by 3 kT or 3 by 2, no? This 3 by, this will be 3 by n kT, 3 by n kT. So here 3 by is equal to, we have kT. So, or basically we have A is equal to, what is the VR? VR is VR is kT. So the option A of the given problem is correct. Both the problem and the solution is clear. So thank you.